sulfate solution. Okay, let's read the words through here. Calculate the grams of nickel sulfate present in 200 mils of a 6% solution of nickel sulfate. And then they're saying the density is that. Okay? Nina, read what the book says. Do you have that handy for 316? How does the book? Listen to if there's a difference or not.
It just calculates the mass of NiSO4 present in 200 mils of a 6% solution of NiSO4. The density of the solution is 1.06 grams per milliliter at 25 Celsius.
Now there's two changes there. One was, they say mass, I say grams. Okay, just to help out a little bit. But notice what else your book added, and I bet the test bank would too. It said at 25 degrees Celsius. We don't use that. I mean, we don't care. All they're saying is you're working about room temperature, because densities can vary a little bit with temperature changes. Because volumes, even though we usually don't think of liquid volumes swelling with heat, they can. And so densities can be a little bit different. But that's garbage here. And I just left it off. But you need to get that skill of deciding what's good, what's not good, or what's useful and what's not useful. Okay, we see a percent solution. And that triggered this, or it should. But there's a second clue up here. They're talking density. Density here. Sarah, what's the equation for density? Mass over volume. Okay, in this problem there's two big clues. That's a pretty good sign. It could very well be a two-step problem. Now, do not memorize that which of these needs to come first. It depends on what you're told. So let's kind of work through what this particular problem tells us. Okay, density, we know that. Then, I know the percent concentration. That's given. Okay, what's going to make our decision here is the 200 mils. Can I use 200 mils up here? No. So that means we need to do this first on this particular problem. Because mils is only going to show up in this density part. So in this particular one, density is going to come first, percent is going to come second. And again, do not memorize density comes first, because we're going to work another problem here in just a moment where density is coming second by what they tell us. Okay, another thing to think about is, and sometimes the problem doesn't spell this out really carefully, when they give you a density, it's for the entire solution. It is never for the solute, it is never for the solvent, it's for the solution, the whole thing. You know, if you talked about seawater or ocean water, what's the density of ocean water? And they would say it's 1.0 something, probably just a bit over 1. They're not telling you the density of pure water or the salt that's in seawater. They're telling you the density of the whole solution there. So likewise in all these problems, it will always be the total solution. So let's try this first. We know this, 1.06 grams per mil. And we have 200 mils of solution. So we can solve for mass. And of course when we solve for mass, that's going to be of solution, because the density was of solution. So let's work that through. And of course you're going to multiply both sides by 200. Mils are going to cancel out. And we're going to get a mass here. Eddie, what'd you get?
212.
212. And the units are?
Grams.
Grams. Okay, now I ask first, are we okay on 6? Yeah, we're just fine. Because how many 6 here? Shout it out. 3. And how many 6 here? 3, because there's a decimal. So we got 3 in our answer. Now, is it reasonable? Sure, because you're taking a number just a hair over 1 times 200. So we expect a number just a hair over 200. So it looks like a good number. Now we got enough, we can go back up here. Because now, you see, we have our 6% once again. Our 100's out there. 212, Charles, where does it go? Top or bottom? Bottom. 212 grams, X goes up there, and nice trick. Divide both sides through by 100. Okay, now I can't do it in my head, but at least I have an idea what the answer should be. It should be a little bit over 12, because in 200, there would have been 12. So let's do cross multiplication, however you do that to get your X. And Brittany, what'd you get? You punched it? Okay, let's punch. Okay, Nina, what'd you get?
12.72.
12.72.
12.7.
12.7 in units?
Grams per milliliter. Grams.
Just grams, because that's mass, and I did not carry units along real well there. Because this is percent, there are no units other than the percentage sign. This is grams, that's grams up there, okay? All right, are we okay on that? A unit analysis of this kind of problem doesn't work really well, because you go, that goes out. Well, no, it doesn't. You gotta keep your grams. Yeah, Andrew?
If the density is the density of the solution,
Yeah.
wouldn't that be the number of grams of solution?
No, this was the number of grams of solution,
Okay.
okay? See, we worked with density,
Okay.
and you've got a good point, Andrew. When you work with density, whatever answer you get right here is gonna be about the solution. But then we took it one step further. We put it here for the solution, and then we solved for the solute. Okay, are we all right on that one? Okay, let's go to the next one. Okay, 3-17, we finally get to change solutions. Okay, 3-17. Take a look at that, the way I have it written. How many clues do you see? How many clues do you see?
3.
3? Okay, Neil, what's the 3? I heard your voice.
15%, 30 grams, and 1.16 grams per milliliter is the density.
Okay, you're answering a different question, really. You're telling me how many bits of info do you see up there? And you're absolutely right. There's 1, 2, 3 bits of info, but how many clues?
Well,
Nikki, what would you say? 2?
Because we have to do the density first. We have to find the volume.
See, I would have said the other way, that's what I was getting at. We have to do the, because you have 2 out of 3% in grams, you'd have to do the other one
Okay.
first.
You have to find the volume of it.
Okay, now, you're both right. Okay, but my original question was, how many clues to give you an idea of how many steps? Okay, percent and density. So Nicole said
two
2
clues,
steps, 2 clues. So probably 2 steps. Okay, then, you're correct too, because you were answering, what are we doing first? Well, hey, we got percent, we got grams of one of our parts. We're going to be doing that first this time. Here's another good hint. If it says volume, yeah, Brittany, what were you gonna?
I was gonna say 2, but there's 2 reasons that you have to, like,
Okay,
first
go.
is the percent, because you have percent in grams, but then the next one is density, but it says volume the first time, what volume?
What
So you know
volume?
the answer is gonna be in volume, so you automatically know the density has to be the second.
Beautiful, beautiful. Did everybody catch that? If they're asking for a volume, this is the only one of the 2 hints that has a volume in it. So I bet it's coming last this time. Yeah, this is a reverse order of the previous problem. So we can do this one first, as Nina said, and we can do this one second because of what Brittany said. Okay, so we've got 2 out of the 3. You always have to have 2 out of the 3 to do this one first. So we know it's a 15.0. We know the 100 is out here. Now, the 30 grams of ferric nitrate there. Top or bottom, Antonio? Is that the solute or the solution, the solvent? What's that 30 grams?
That's the top.
the top, the numerator or the solute, exactly. Because you're saying grams of that, we are assuming, what's our solvent? What's our solvent? It doesn't say, but we assume, it's water, yeah. So here, we can solve for that. We can solve for grams of solution. So again, an easy way, divide both sides through by 100. Once I do that, then it makes it easy to do it in our heads. Mark, can you do it this time? 15 is in 100, 30 would be in,
200.
yeah, 200, yeah. It'll be 200, point, thank you, good. And the units are grams, and it's grams of what?
Water solution.
Of solution. Okay? Yeah, Andrew?
And you know there's 30.0 grams because it's 30.0 grams of FeNO3.
Yeah.
So we know that that's why
That's-
it's the
yeah.
solid.
Because we always assume waters are solid, so you know that is the solute or the numerator. Okay, so we get 200 grams of solution, but they don't want grams of solution, they want volume of the solution. So we're all set, ready to go with this one now. 1.16 grams per mil is equal to,
200.
we got 200 grams over X. And this is the kind, when we were having problems with density, that was the hardest way to go for people if their math skills were a little rusty, because your unknown is down here on the bottom. So this would take 2 steps, algebra-wise. Multiply both sides through by X, get X over here and on the top, then to get X to stand alone, divide by 1.16 on both sides. Grams and grams cancel. Volumes come around to the top. Okay, now, here is one other way you can think about density if algebra just gives you fits. You can think of it. 1.16 grams in 1 mil is equal to 200 grams in X mils. And we just turned it into a ratio and proportion. Whatever does it for you. Okay, but we will get the same answer, hopefully, either way we do it. So we're going to divide this out. And Charles, what are we getting? Have you punched it? Yeah, I want milliliters.
172 milliliters.
172 milliliters. Okay. Is that what other folks got? Okay. Now, anybody have a question about percentage? We've worked it just about every way we can on a percentage. Where we did the first 3, which was just percentage, end of story. Then we threw in the complicating thing of the 1.16. Okay, well, before we move on to the next, Andrew, read what the book says for this one.
For 17.
Yeah.
What volume of a solution that is 15% iron nitrate contains 30.0 grams of FeNO3? The density of the solution is 1.6 grams per milliliter at 25 degrees Celsius.
Okay, the only difference was, it mentions the temperature, but temperature is not going to affect how we work this thing. It just says 25 degrees Celsius is just about room temp. In fact, I think that's 77 degrees Fahrenheit, so about room temp. Okay, let's shift gears if everybody's comfortable with percentages. Well, now, medical people may like this percent business for their solutions, but we as chemists don't. We use something called molarity, and it's abbreviated with a capital M. And I usually underline that to be sure you know it's a capital instead of a lowercase m, because if you go on and take 1412, lowercase m stands for something else. So M stands for moles of solute over liters of total solution, over total solution. That is an arbitrary definition that somebody pulled out of their ear. And I don't care how smart you are, if you hear the word molarity for the first time, you will never crack this code. I mean, it'd just be a guess at best. Whereas percentage, concentration, if you think mathematically, you could probably reason that through, part over the whole, times 100. But here, molarity is multicellular over liters of solution. And I want to have a warm-up problem first, before we hit the ones in the book.